Okay, 8th graders, today we're talking about discrete and continuous domains, and our essential question is, can you decide whether the domain of a function is discrete or continuous? So first, a discrete domain is a set of input values that consists of only certain numbers So, for example, when you graph a discrete domain, if I were to graph it on a number line, it would just be the points on the number line. So 1, 2, 3, 4, and 5. It's not anything in between. It's not 1.5. It's not 3.279. It's just 1, 2, 3, 4, 5. So it's things that can only be whole numbers. A continuous domain is a set of input values that consists of all numbers. So, using the same example, it could be every number between 1 and 5. So it's like a line. It includes everything. Let's take a look at an example. The function y equals 15.95x represents the cost in dollars of x tickets for a museum. Graph the function using a domain of 0, 1, 2, 3, 4. Is the domain of the graph discrete or continuous? So 15.95x times 0 is 0. So the ordered pair is 0, 0. 15.95 times 1 is 15.95. So the ordered pair is 1, 15.95. Number 2 is 15.95 times 2, and it's 31.9. So our ordered pair is 2, 31.9. 3 is 15.95 times 3, which is 47.85. So our ordered pair is 3, 47.85. And 15.95 times 4 is 63.8. So our ordered pair is 4, 63.8. Now, we have to decide, is the domain discrete or continuous? Well, we're only considering x values because x is our domain. So if we're only considering x values, and here my x values are talking about tickets. Can I buy half of a ticket or 0.1 tickets? I can't, so my domain is discrete. So all I have to do is look at the x values and decide, can I buy parts of whatever the x represents? And if you can, it's continuous. If you can't, it's discrete. Then the next one, the function m equals 50 minus 90 represents the amount of money m in dollars you have after buying D DVDs. Graph the function. Is the domain discrete or continuous? Well, if I buy one DVD, $50 minus 9 times 1 is 9, leaves me with 41. If I buy 2 DVDs, so these are my D's and these are my M's. If I buy 2, 50 minus 18 is 32. If I buy 3, I'd have 23. If I buy 4, I'd have $14 left over. If I buy 5, I'd have $5 left over. So all I'm doing is looking at my domain, which in this case is represented by the letter D. And am I able to buy parts of DVDs? No. So again, this is discrete. A cereal bar contains 130 calories. The number of calories consumed is a function of the number B of bars eaten. Graph the function. Is the domain of the graph discrete or continuous? So one nice thing about these is that it tells us to graph them, but we don't really need to. We can decide whether or not they're discrete or continuous all on our own. So if we have an input of 0 bars, 130 times 0 is just 0. 130 times 1 is 130. So if we eat 1 bar, we're consuming 130 calories. If we eat 2 bars, we're consuming 260 calories. If we eat 3 bars, we're consuming 390 calories. And if we eat 4 bars, we're consuming 520 calories. So on this one, our input or our domain is the number of bars that we eat. So can you eat just 1 bite out of a bar, or can you eat half of a bar? Of course you can. So the number of calories is continuous, because you could eat any portion of a bar. Okay, next one. A 20-gallon bathtub is draining at a rate of 2.5 gallons per minute. The number G of gallons remaining is a function of the number M of minutes. Graph the function. Is the domain discrete or continuous? Okay, well, if we have a 20-gallon bathtub, after 0 minutes, we have 20 gallons. After 1 minute, we have 17.5. After 2 minutes, we have 15. After 3 minutes, we have 12.5. After 4 minutes, we have 10, and so on and so forth. So we have to decide, is our domain discrete or continuous? Can I have a tiny, tiny part of a minute? Of course, it's a second or a millisecond. So I can have any number in between all of this in amount of gallons. So that makes this one also continuous. Are the data shown in the table discrete or continuous, and explain? So if we look here, we have the number of stories in a building and the height of the building. Well, can we have half of a story or a tenth of a story of a building? No, we only have full stories of a building. So this is discrete because we can only have full stories of buildings. Okay, you have 3 problems to try on your own. I have given you the graphs. However, you can probably determine whether they're discrete or continuous without the graphs. So all you have to tell is the domain discrete or continuous? And remember, only looking at your x values. Have a great night.